Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. It was a question in an admission test for the University of Cambridge, so let's see if we can solve it. Find the real non-zero solution to the equation that looks like this. We get these 6 answers here, and we have to find the correct one. So let's take our equation and let's see if and how we can solve it. We have 2 to the power of 9 to the power of x over 8 to the power of 3 to the power of x, and all of this equals 1 over 4. We have an exponential equation here because our x is in the exponent. And maybe we first simplify the things a little bit because here we have base 2 and here we have base 8, and the 2 is actually a part of the 8. So if we take our 8 to the power of 3 to the power of x, we can find the 2 in the 8 as well, because the 8 is 2 times 2 times 2. So we can write the 8 as 2 to the power of 3, and all of this then to the power of 3 to the power of x. So we just wrote the 8 like this. And now we have base 2, what we wanted. And now we are allowed to multiply the exponents. So we just keep the base 2, and then we take this exponent, the 3, and multiply it by this exponent by 3 to the power of x. So instead of this expression here in the denominator, we can write it as this, where we have base 2 as well. So let's do this. We don't change anything in the numerator. That was okay. But here, instead of this expression, we're going to use this one where we have base 2 as well. The more similarities we can find, the better. On the other side, we still have 1 over 4. Okay, now we have a power of base 2 divided by a power of base 2. There is a rule that we can just take the base and then subtract the exponents. So we take this exponent here, the 9 to the power of x, and then we subtract this exponent, the 3 times 3 to the power of x, and all of this is still 1 over 4. Okay, so instead of this big fraction, this is how our equation looks like now. And if we take a look at both sides now, here we have 2 to the power of something, and here we have 1 over 4. So if we take a look at similarities, the 2 and the 4, we can find the 2 in the 4. We can write the 4 as 2 to the power of 2. So let's do this. Instead of the 4, we write 2 to the power of 2, so that we can see that we have base 2 here as well. But on the right side, we have a fraction. On the left side, we have a power. But we can always write a fraction as a power as well. We have 1 over a power, and we can always take the power, so the 2 to the power of, but then I have to make this exponent negative. So instead of the 2, I'm going to write down a negative 2. So instead of this fraction, I can write it as this power. And now if I compare the two sides, I have base 2 here and base 2 here. And I have 2 to the power of this thing and 2 to the power of this thing. The bases are the same, so these orange exponents have to be the same as well. So I can just take this orange thing and set it equal to this orange thing. So 9 to the power of x minus 3 times 3 to the power of x has to be equal to this orange thing to the negative 2. Okay, so this is our equation now, where we have 9 to the power of x minus 3 times 3 to the power of x equals negative 2. So if we compare the bases here, we have base 3 here, base 9 here, and if we look for similarities, we can find the 3 in the 9 here as well. We can write the 9 as 3 squared, and then we have to raise it to the power of x. So let's write it in parentheses and raise it to the power of x. And let's write down the rest of the equation, because now we have base 3 here, we have base 3 here. Okay, here we have exponent x. Here we have exponent 2, but also kind of exponent x. But what we are allowed to do is to switch these two exponents so that we really have 3 to the power of x in here. So let's do that. Instead of raising it to the power of 2 first and then to the power of x, we first raise it to the power of x and then to the power of 2. So now we have 3 to the power of x here and 3 to the power of x here as well. We still have the negative 2 on the other side. Maybe we bring it to the left side as well. So let's just add the 2 on both sides of the equation here and here, so that we have 3 to the power of x and all of this squared minus 3 times 3 to the power of x, then the plus 2 from the other side, and on the other side, this cancels out, and we get a 0. Okay, so this is our equation now, and why am I so happy that we have 3 to the power of x here and 3 to the power of x here? If things repeat in an equation, and they kind of look complicated, we can use substitution to make this equation easier. So instead of this green 3 to the power of x, I want to replace it from now on by another letter. You can choose whatever you want. I take a u. So instead of the 3 to the power of x, instead of this green thing, from now on, I'm going to replace it by a u. This is my substitution. It's a common thing to solve equations that are a little bit more complicated, to substitute something that is more complicated by something that is pretty simple. So let's write down the equation in u then. Instead of the green thing, we're going to write a u. So we have u squared minus 3 times, then we have our green thing again, we write a u instead of it. Then we have the plus 2 and then the equal to 0. This equation is much simpler than this one. So our plan is to solve this equation first. And if we have the solutions of this equation, then we come back to our substitution and find the real solutions to our original equation. But first of all, we have to solve this equation here. It's a quadratic equation, so we could solve it by using the quadratic formula, or if the numbers are nice enough, we could also solve it by factorization. And I want to try it. I want to write the left side of this equation as a product so that I have a product is equal to 0. Because of the u squared, I'm going to have a u here and a u here. And now I have to find two numbers. I call one number a and the other number b, and I know that if I multiply these two numbers, so if I have a times b, then I will get this number as a result, so 2. And if I add these two numbers, so a plus b, then I will get this number as a result, so the -3. So which two numbers do that for me? If I multiply them, I want to get 2 as a result. For example, this could be 1 times 2. But if I add them, do I get -3 as a result? Well, I have 1 plus 2. No, that equals 3 and not -3. So I would need some negative numbers here for my product, which gives me 2 as well, would be -1 times -2. And if I add them, so if I have -1 plus -2, yes, this gives me -3. So I found my two numbers. I have -1 here and -2 in here. So now I can solve this equation because I have something times something is equal to 0. So I know that either this thing has to be equal to 0 or this thing. So I can write down two smaller equations by taking the first part, u minus 1 has to be equal to 0, or the second part, so u minus 2 has to be equal to 0. Let's solve this equation for u by adding 1 on both sides of the equation so that we have our u. This cancels out, and this is equal to 1, our first solution. And here, to solve for u, we add 2 on both sides of the equation so that we have our u. This cancels out, and this is 2. This is our second solution for u. Let's go back to our substitution. We found u solutions to this equation. Were we really interested in u solutions? No, we are interested in our x solutions, but we can use these solutions now because we can insert them here for u in our equation here and solve it then for x to find our actual solutions. Let's start with the first solution. We have to do the same thing with the second one, but we start with the one we inserted here for u. So we have 1 equals 3 to the power of x. Let's solve this equation for x to find our first real solution to our equation here. It's an exponential equation. We can solve for x by using the logarithm on both sides. Log base 3, so we have on the left side log base 3 of 1 on the left side. And on the other side, we also have log base 3 of 3 to the power of x. Log base 3 of 1. If we have a 1 in here, this is always 0. So on the left side, we just have a 0. And on the other side, if you have base 3 here and base 3 here, they cancel each other out, and only this exponent is what is left, so only our x. We found a first solution, but in the problem they said find the real non-zero solutions. So 0 is not a solution for our case here. So far we haven't found any solution yet. But we also have a second u, so let's insert the 2 in here so that we have 2 is equal to 3 to the power of x. Let's solve this for x by applying the logarithm, base 3 again, so that we have on the left side log base 3 of 2 this time is equal to. If we apply the log base 3 here as well, we can see that it cancels out and only the x is left. We found a solution. Let's see if we can find this solution here in the answers. Yes, it's answer A, and we solved this problem. If you liked my video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!